Hello, welcome to the stream. It's day two. Can you believe it? Day two of our holiday stream, and hopefully we'll get some interesting things done today. Thanks for coming back. And I was just checking. Rust 1.75 was released today, or maybe it was yesterday. I forget. But anyway, I ran Rust up, so we're on the latest, which is cool. There's some neat features in it, none of which we will be using. uh, so, um, but do check out. They do release on a very regular cadence, and those updates can be really impactful on the kinds of code you can write. One of the most exciting things about this latest release, in my opinion, is the asynchronous functions and traits. Um, and for a while now, you've had to use an external crate. Hasn't been in the standard library. And basically, it would fake it. Um, but now there's full support for it in the compiler. There's also, I think the thing that was released this time was it was either I think it might have been type alias traits, um, or it might be return position infiltrate, which I think we've already had though. So it's probably not that. It may have been the return position infiltrate in a trait definition, um, but I'm not so sure about that. So anyway, cool stuff in the latest release. I have recompiled our game work in progress. Um, but one thing I want to do before we get started with developing some of the features of our game is we're pulling in a lot of features that of Bevy that we're not using, um, especially the stuff related to 3D models and whatnot. So we're not going to make use of those. We're trying to do a sprite-based game, so we can cut down on some of the stuff that Bevy pulls in, and hopefully speed up our compile times. That would be nice. Excuse me. Okay, so let's get started. All right. So last time we were looking at knockback. We will get back to that. I don't know that we'll do inelastic collisions. I think that's probably venturing too much in the territory of, oh, we actually need a physics engine. I think we just need to think more carefully about how our knockback is created, and then also consider we might be able to simplify some things about the game, maybe spawn only one ghost, for instance, so that we can repeatedly test that functionality. Um, and maybe we'll get to some, like, I'm actually looked up yesterday and this morning some stuff about procedural generation. So we might be able to do some, like, we could look at the tiles that come with this tiny dungeon set that we got and see if we can generate a game space that has background tiles that are kind of generated with like a random walk type thing, or like a cellular automata or something like that. That would be really cool. Um, yeah, so let's start with cutting down on the stuff that we use in Bevy. So we've got so this is I've bookmarked the Bevy docs, so I don't have to keep typing it every stream. The default features enables basically most everything, um, but we're not. This is just a demo game. We're not planning to release for Android, so we can disable that. We might need animation, so we'll probably leave that in. Asset, audio, core pipeline, that's fine. Um, I'm not going to add gamepad support, so we don't need GilRS. Maybe Gizmos is useful. GLTF is for 3D models in the GLTF format. We're not going to do that, which means we don't need PBR rendering either. That's physically based rendering. That's like it's got a whole pipeline of shaders, and they emulate physical phenomena to do rendering, and that's more of a 3D photorealistic type thing. That's not what we're doing. So we can remove that. We'll keep render and scene sprite and text and UI and win it. We might want to pull in our own font, so we'll see about that. I'm not sure. We won't need HDR or KTX2 textures. We'll probably want multi-threaded. So let's get started. See if I can. Yeah, there we go. Let's get this pared down. So we're in the cargo toml, and this is not exciting administravia, but and we'll say default features false features, and then let's start listing them. So animation, Bevy animation. We may not use those, but if we ever have any canned animation, say like maybe there's something where our character is swinging their sword or an enemy does something, then we'll probably want those to define those animations. I don't know any tools that we could use to export that, but we'll see. Okay, Bevy audio, Bevy core pipeline we obviously need. Cargo, I wish we had a way to make this easier. Be like default features except these. That would be nice. Okay, we said we don't need GIL-RS. Let's keep the gizmos. I'm not sure if we'll use those. This might be useful for visual debugging. Okay, we don't need GLTF or PBR. We need render. I think scene is for 3D scenes. Let's leave that out for now. We definitely need sprite because we're using that. Let's keep text. Yeah, so GUIs. I'm not sure. We don't need this yet. Maybe let's put this in here and just like disable it. We definitely need WinIt. We don't need the default font. We don't need HDR KTX2. We want multi-threaded. I think our tiles are PNG, so we definitely need that. This one is a question mark. I guess we'll try rendering without and then see if that's needed. We don't need Vorbis, Ogvorbis for audio. We'll probably use MP3 later. We don't need WebGL2. We want X11. And we don't need Z standard. Okay. So Rust Analyzer is going to build that. And it's got to rebuild all the crates. So let's see if we can build. Yeah, it's waiting on the lock. And hopefully this will be a cut down version of our dependencies. Looks like not too many things had to rebuild, so that's good. No, there's also a bunch of optional features. You know, we could add some of these things later if we think we need it. Maybe FLAC or MP3 support, or JPEG. I don't know if we'll need that. And there's a lot of audio related things. We might later want to have, or maybe we'll have this in a build profile. but have tracing support, where we could use something like Tracy or whatnot to do profiling. I'm not really that. Yeah, okay. Chances are we probably need Bevy scene. So let's look at the prelude and see if there's a see ambient light. It doesn't say anything about what feature that requires. Okay, and they don't have their docs labeled with what requires what features. But what we can do, hopefully, oh yeah, I forgot they disable source on their stuff too. All right, let's go to the repository. Hello. Okay, so source. Use Bevy internal. Okay. Let's see what's in the prelude. Okay, so this is just re-exports, right? Let's make sure it's not in Bevy scene. If it is, then we have determined what we're missing. Ba, 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 ba. Scene bundle, dynamic scene bundle. That's not it. Let's look for its ambient light. Ambient light. Let's make that more specific. Say struct ambient light. Okay, so that's in PBR. So unfortunately, I mean, we can remove that and see how our game looks, and then if we need to put it back, we'll put it back. So let's comment this out first. And let's. Oh wait, wrong one. What did I just edited the wrong file. I had the tutorial project up, so I meant to look here. Let's comment this one out, and then if it's not bright enough, then we'll put PBR back. It looks fine. You know, we're fine. I'm not worried. Okay, we don't need that ambient light because it's sprites. So we can actually fully remove that. That's great. Okay. Okay, cool. So now that we've got that pared down, okay, so we're going to pare down the Bevy features we have enabled. Okay. Cool. So we have that cleaned up a little bit. You know, for the most part in developing, um, we haven't needed that because the dependencies don't change, right? Um, so we don't have to be concerned about that often. But for a fresh build, it should take a little bit less time. Okay. So, and let's look at the other one. I need to revert this change I made over here because it is actually using 3D. I also wanted to look at some of the stuff that is in this tutorial project that we can crib from, because I think they've done a good job of anticipating some of the problems, and we can probably take some learning from it. Interestingly, I was looking at the how they do movement, because that was one thing that we were struggling with. We wanted to add that knockback effect on the player, and we wanted it to happen despite any sort of like movement input that they're giving. So if we look at their movement systems, they have update velocity first, so it's applying the acceleration to the velocity as you would expect. And then they update position, so they put these in a chain, and that way the acceleration is correct. However, if you look at their spaceship, their input handler, so the movement controls on this, they basically just apply the velocity. So the amount of movement is like, it has a speed that's constant, and you're either going forward or backward. And they're using this transform dot forward gives you a vector pointing at the direction that your scene is facing. For us, it's not going to be relevant, but then that's a unit vector, and they just apply, the magnitude of the movement to it. So they're not accelerating the spaceship at all. Which, yeah, I mean, that's a quick way to do it. I think that if we want to have these more complicated movements, that's not going to work for us. But the other thing I wanted to look at too is, I've mentioned it multiple times. They have a schedule thing, so I think that what we could do is make our own schedule. And this is sort of like, when I say schedule, it's a system set, and it lets you adapt or like make finer grain scheduling decisions within one of the built-in schedules, right? So what did they do in theirs? So they have something that despawns entities first, and there's this implicit flushing the commands. So this despawn is basically, it's going to use one of those commands objects, and it's going to find an entity and despawn recursive. So like despawning any things that are associated with that entity, including children entities. And then in order for that to make sense on this go round of the loop, you have to apply the commands. Otherwise, they're applied in post update, I believe. So anytime we're spawning something, it may not show up until the next loop. Anyway, so then they process user input, then they do any entity updates, and then they check collisions. So we could do something like this. I actually don't like the name of this, but we'll have some similar things here. And then when we go, and notice they say add systems to update, And it's apply deferred is a built-in system. It's in the ECS scheduler. And that runs anything like commands that you have enqueued. And they're saying run it after despawn entities systems and before user input systems. So putting it right there in between. Excuse me. So, and then when you've configured these sets, you can, for instance, so like we were looking at movement, you can, queue up, chain up these two systems, update velocity, update position, which will do something like that. And then you tell it put this chain into this set of updates or this set of systems. And then for despawn, here's this despawn faraway entities. There's just don't, just throw away things that are outside the visible screen. And that runs in the despawn entities phase. So this is sort of the, I forget what they called it before, 0.12 or maybe 0.11 that Bevy introduced this, but there was this concept of schedule free. And it was more that you were no longer bound to the scheduling that the Bevy ECS does automatically, and you could define your own schedules. Yeah, this is good stuff. So, excuse me. So this inset, yeah, it is a function on any system, any function that implements system. So, okay. Let's see. Let's see if there's anything else we can learn here. Yeah, we looked at their collision detection yesterday. Basically, oh, right. So one thing that we could do is parameterize our collision handling, but we're not actually doing that properly anyway, because they're saying despawn. Let's see what theirs are. Right, so they run collision detection in that subschedule, and then they run the handling collisions in despawn, and they handle it by by type. So this is saying if it has this component on it or this component on it, this helps them, if asteroids collide with asteroids, you don't destroy them. They just keep going. But if an asteroid collides with a spaceship or with a missile, then yeah, it's going to be despawned. Okay. Yeah. So let's switch over here. I think we should maybe consider doing the schedule thing. We'll be able to think more carefully about the ordering of our systems, because we've been very, very modular in this so far. Yep. All right. Let's make a schedule module. And if you have any questions or suggestions, please feel free to drop them in the chat. Say hi. We'd love to hear from you. Otherwise, I'm just coding and talking to myself. It feels kind of weird. So, okay. So we are going to do something similar to what they did. We'll do a schedule plugin like before. Okay, and then in here, yeah, we can leave the to do for now. In there, we can implement our, configuring the system sets. So let's. Hello, English M underscore. Welcome to the stream. So let's say. Now they were doing. They said in-game set. I think we may want to do something similar to that. Because we might have different subschedules depending on what kind of state that we're in. Let's just call it in-game. I don't like in-game set. It feels weird. So let's define user input as a phase, and we're going to define entity updates as a phase, and then we're going to define collision detection as a phase. Okay, and then I don't think that we needed anything special for that. We need to get this stuff, yeah. So it derives system set. Obviously, this is a really simple enum, right? So we can, we can get all these things for free with derive. Okay, and then we're going to say configure set. Configure set or configure sets? Configure sets. Okay. And hi, Chris. Welcome to the stream. Okay, so we're gonna set up this chain of phases, right? And I don't know that we need to do anything else there except we're gonna do user input and then entity. Except we need to define that in-game entity updates, in-game collision detection. We might want to have another phase here, which is like, similar to their despawn entities phase that they put in the example. Maybe it's something like, I don't know, handle collisions, or and we definitely want to have that before the user input in case we have to say delete or like despawn an enemy that we have defeated, for instance. So let's name it entity. I want to say something like handle combat or process combat. Let's call it that. It's not good. We'll change it later, I'm sure. Naming things, the hardest thing in computer science. Okay, so we're gonna do process combat, and those systems may take commands. In which case we want to do, let's see here. We want to add systems, and this is update, and we're going to do like what they did before. So apply deferred, and before in-game user input, and after in-game process combat. Okay, I think that will do. Hopefully, we're not getting any compile errors. Of course, we're not adding this to anything yet, so let's go ahead and add plugins. Schedule plugin, and now let's see what the compiler errors are. Okay, we did all right. No problems. Okay, so now what we can do, since we have these phases, we can start to look at the systems that we have and put them into the various subschedules. So Let's start with collision because I think that one, you know, uh, let's not let's comment out our knockback player for now. Um, I'm gonna say this is in set, in game, collision detection, right? And maybe we'll. I'm gonna comment out this whole thing. I think that we had the wrong idea there. Anyway, okay. And let's see what's wrong. Oh, right, because we're not using those. Those are just warnings. Okay. We can remove that for now. Okay. And let's look at this, see if there's any. So we want to we probably want to do the chase player in the entity updates set, right? Oops. Can you use that? Yeah. So that that's about making sure that the ghosts move, they follow the player around, right? That's our chase. Okay. And then the spawn ghost, I suppose we could do in the handle combat. That way we are, but actually it doesn't really matter. It doesn't matter when that one happens. Okay, and then let's look at health. So take damage should be in the maybe that should be in the combat, because we know at this point what you're colliding with, right? We've just computed what you've collided with. So let's do that in the process combat, right? So you'll take damage at the beginning of a frame, not in the middle of the frame. Okay. That's good. It's feeling good so far. Okay, let's look at movement. What's wrong here? We're not using accelerate. Okay. Well, let's not worry about that right now. Okay, so update position is going to go in set, in game, entity updates, right? And maybe we'll have a update velocity later, like the other thing did, if we need that. Okay, and then the player has only movement, so that's going to be in the cat. My cat has shown herself for today's stream as well. Okay, so that'll be user input. Now that'll happen before we actually update the player, which is good. So then we can run our input handling, and yeah. Okay, anything in the camera? Nope. Asset loader? Nope. Cool. Okay, so this should materially not change anything in our program. If it does, then we probably have a bug. Okay, we don't need to care about accelerate. We're still moving just fine. We're detecting collisions, taking health damage. Cool. With the cooldown. Cooldown's probably still too small, but we never did implement knockback. Okay. So What shall we do next? Let's make a commit real quick. Okay, so here we're adding more fine-grained schedules for systems. Okay. So now when we have something like that knockback, what we can do is put it in the process combat phase, right? And I think that I think we had this in collision. Yeah. I don't think this is appropriate in collision because collision should only be about detecting, not what to do. I think we maybe need like a combat module, which is, you know, add systems to various phases depending on, you know, what's important. So we're going to completely rethink this. I think we'll just delete it. And then, yeah, we can remove it from here too. And we'll rethink that. So I know, Chris, you've used Rapier 2D for some things like this. I don't know if you had any interesting stuff in your block breaker game with that, but we're going to muddle through. I think it's important that we really try to get this knockback idea correct. So let's make a new module, and I'm going to call it combat. And okay, and we'll do this dance again. I almost think I should set up some kind of template to paste this in for me. Oh, yep, okay. Okay, using character control is probably really the only interesting piece. Okay, yeah. Okay, so let's leave this as to do, because I think we want to think about what the components are, and then we want to do some like we want to adjust the velocity of the player, which makes me think that in here, probably what we need, rather than changing the direction and speed, we need to like apply the player's input direction, right? Rather than directly changing it. Because if we directly change it here, and then we want to have this knockback, it's not going to do anything if we're immediately overriding that velocity. So that's a weakness in our current system. But let's focus on making let's make a component that represents our knockback. And this is going to need a direction, which will be vec3. And let's just make that pub. There's no reason not to. And then we want like a duration, which is going to be a timer. So what we will do first is probably let's figure out how to apply the knockback component, and then we'll figure out how to add it when a player collides with something. So direction and duration. So this is like, the direction is more like let's call it displacement, right? And So let's make a system that is apply knockback. And this is going to take a query which has, obviously it has knockback. And since we're going to tick that timer, we need this to be mute. And then we need mute velocity. And I'm not going to specify that this is only for players, because we might want to apply knockback to enemies when we strike them. So if we hit them with something, or we hit them with a specific kind of weapon, maybe they get kicked back as well. And then we need the elapsed time. Okay. And so we'll say knockback velocity in query itermute. I'm sorry, I'm going to lean on you a lot since you're here, Chris. Do you usually use itermute, or do you use and mute query? Just out of curiosity. And this needs to be mute here. Okay. So we're going to say see, we want to apply. I've been moon turned and mute recently. No real reason for that, though. Okay. It might, maybe looks nicer. I don't know. Maybe we need to sketch this. The idea here in my mind is we have a total amount of displacement we want. And I think that, so let's do, it's really about, we need to add velocity of a proportion of this displacement based on the amount of time elapsed, right? So let's first tick the timer, because we have to do that on every duration tick. And then we'll say time.delta. We have to do that regardless. And then so really, is this displacement and an acceleration? I think we thought about this before, right? Okay. So we only want to do this if the timer has not finished. You know, it probably doesn't matter. It doesn't matter whether this right now, whether this is an acceleration or a velocity, because if we think about it as a velocity over time, that's going to be a position displacement, right? So maybe what we need here is actually transform. Let's instead of velocity, let's do transform, and let's see if that might work better. Okay, so now we're going to apply this knockback displacement times time delta seconds. And that way we're actually moving the player, right? We're not trying to apply a velocity that's overridden later. I think this is probably the easiest way to get this done. And then this displacement is actually an amount, like an actual physical distance, right? And then we can when we add the knockback to the to the player when it's colliding with an enemy, then we'll compute like an amount. Maybe the amount is constant, but we really just need a unit vector in the direction we want to push the player away, which we did in that previous version of this system, where we computed all the things that were colliding with it and like a vector that was based on, you know, the opposite direction from where those collisions were coming from. And we'll do that again down here. So, okay, so this is like, let's add systems. And this is in update. And we're going to, let's start with a tuple here. We're going to use that. We're going to put this in the process combat system or schedule. And let's put apply knockback. And then we can get, I'm going to put chain. We can get that if we have other systems here that we need to go in the process combat phase, we can chain them in specific orders. Although like a chain on a single tuple of, you know, a unary tuple of systems is not that useful. I'm just trying to prepare us a little bit for later. Okay, so now we need to get knockback on our we need to get knockback on our player. So we're going to actually I think this needs to be, need to think about this. This actually should be not chain, because we want to apply this in the entity updates. And we want to have a system which is like knockback player or add knockback, and we're going to put that in the set process combat, right? Which was the, we need to add knockback, apply knockback. Knockback collisions, I don't know, naming is hard again. Okay, so here's where we're going to add that, and then let's make sure that that's fine. What's our warning here? Yeah, we're using accelerate. Actually, let's just go in there and delete that. We don't need that. We will probably want to think about those sorts of things later. One of the interesting things about what we've done here with this is it's irrespective of the user input. So even if they're trying to move continually into the collision, we're going to kick them back. So okay, so what do we want in here? We need some commands to add this knockback component to the user. One thing I should also say is we're going to need commands here, right? In that we need to remove that. And I'm going to put it to do here, remove the knockback, the expired knockback component. Okay, so this particular thing is going to need the commands to add the knockback to the thing. And then our query is going to need to be, we're going to need the entity so that we can use commands to add that component to it, right? And we're going to need the collisions collider, was it? Yep. Okay. And so this is going to be the you think about this. Okay. You can see my cat's tail. And you probably hear her purring into the microphone. Okay. I think we need to start with this. I'm not sure what else we need here yet. So let's see about that. Let's make a game plan. So we're going to actually I'm going to make this player for now, because I think that we want to filter it. We only want to handle knockback on the player for right now. What we can do later probably is do, T, which is component like that. Maybe we just do that. Similar to what they did in the other example. And let's do player. And we'll only add knockbacks on the player for now. Okay, so we are going to on our collisions, yeah. So we didn't have any cooldown on that, and I don't know if you can combine filters here. Let's look at that. See if you can combine, because what I would like to do is have. Here, let's just go back to there. With. We would like to add a knockback for things that don't have a knockback component. So maybe the other thing we can do is actually, having it in here is just an assertion that it has that, and we can ignore it, and let's do without knockback. So we'll only add knockbacks for entities that don't already have it, right? Okay. So now, and then we also need the transform of the so we're talking about the player here first. Because we need to compute that, and then we I'm going to call this collider and collided. And what we want here is the transform. This is so we can compute that vector between the centers of the objects. And we can filter it to only things that have a collider. That way we get we can look up the transforms for the things that it collided with, right? Okay. I think that's probably enough for now. Okay, let's set a constant amount. knock back distance. And let's make it a little big. Let's make it like, you know, our sprites are 16 by 16. So let's do like, I don't know, three times like. Let's make 48 be the knockback distance. That's pretty significant. Okay. So let's get started. So let's look at entity, and then this is collider and transform, and we don't care about that in collider.iter. Okay, and then we're going to loop through oh, cat, careful. She nearly rolled onto my keyboard. We're going to loop through the, oh, and I aliased that. I need to collide. Oh, yeah. I was imagining a knockback that bounced the player off of both sides of the screen before settling. Now that would be funny. Okay, so we need to loop through the collisions. This is going to be well, entities are copy, so I'm not really concerned about that. I'll just deref it when we have to use it. Okay, so what we can do is okay, we're going to let the direction back 3 0. Remember what we did last time was we added up all of the distances between the centers of these things to compute a net direction of the collision. So if these things actually came together like this, you know, this one would be sent this way and this one would be sent this way, but we're only doing knockback on the player, so it's just gonna be like bonk. Okay. So let's take I'm forgetting everything. So and that's gonna be, we need to do star there. So if we can get the transform of this, and remember we do the direction of the arrow is the endpoint minus the start point, so we want it to go away from the thing that it ran into. So we want that direction to be the transform.translation minus the collided transform.translation. So now we should have, you know, honestly, this could probably be panicking. We shouldn't have something that you collided with that doesn't have a collision component itself. But I'm just going to be a little bit paranoid there. That seems like, oh, that's not some. That's okay. Okay, so now we've added up the direction that it should be knocked back. And we want to normalize that. Okay. So we want to commands entity insert, I think it is. Yep. So insert is how you can add a bundle, you can add, a component. And we're going to add a knockback. Okay, and we need to fill that struct fields. So our displacement is going to be direction.normalizer 0 times knockback distance, right? So we've got the direction we want it to go, and then we got the amount that we want to go, and there's our displacement. And then let's pick something arbitrary here. So we're going to say from timer from seconds. Let's make it do timer mode once. A 1/10 of a second. We want it to be pretty short. Now, the other thing that we need to probably handle up here is this displacement is relative to the duration of this timer. And so we probably want to adjust this by duration dot too many extra stuff on there. Here's duration. I guess we can do duration dot as seconds. Right, so we're here scaling the amount of time that has passed based on the duration of the timer. So if this next tick is in like 5 milliseconds, we only want to displace like 5% of the amount. I think that's correct. All right, so this is a lot. Let's add the combat plugin to our main if we haven't already. We can just put it down here. Yeah. Okay, let's look at this file. Have a look here and see if we need to do anything. What's wrong here? Oh, has sex F64. F32. There we go. Now, since this is only a proportion, we could probably do delta. I don't know if duration implements div. Let's find out. It does not. So it has this div duration. It's experimental. Of course it is. All right. Okay. This should be fine. Um, yep. Okay, so let's see if we can. Now we're only going to get one knockback. Why did you start using nightly? I needed an F64. Yes, this is the tale's old as time. Um, we're only going to get one knockback because we're not removing the component after the knockback is processed. Um, and I actually think that so we could have that penultimate step where we're not applying the knockback on this. So if it's the last tick, we'll need to think about that. But let's try this. You know, like there's so much of this that needs to be experimentation. Okay, so our player's here. We can still move him. Let's see what happens when a ghost runs into him. And it doesn't work. Okay. Um, so clearly this is not working. Let's put this outside just to be sure. And let's go ahead and do it like this and say we need commands. And we probably need the entity here, right? And commands dot entity. I don't want to remove that. Not remove resource. Let's look it up. Okay. Let's see if it's on this entity command struct. I don't think it is. Oh, okay. So it's a parameterized over t. So that was correct. I'm not familiar with that. So we want to remove knockback, right? Yeah, so that removes that component. And let's see if this yep. We could potentially put some log statements in there. I know we had that in that health one. Woo! Yay! He gets bumped. Look at that. All right. Boom, 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 boom. You got hit. Oh no. It's he gets hit a little far, and yeah, and you get knocked off the screen. Okay. Um, that was fun. Okay, so we got knockback working. Woohoo! It's, we'll need to do some tuning on the numbers there. But game over. Yeah, totally. It's like I got knocked off the screen. Okay. Um, that was fun. Okay. Yeah, and we'll probably 48 is pretty big. Let's drop it down to 2 player units. Being 32, and I think it's good to, as much as we can, keep these things in constants, and you don't have to dig down in here and like, what did I set? So for example, this should probably be, um, and we should find other magic numbers and put them into constants. Duration, that's 0.1 seconds, and let's put that knockback duration. And then our system doesn't rely on um, having that magic number in the function itself. It can be out here, make it easier to tweak. And we probably have that some other places. I think with our health thing, we probably did it. Yeah. So let's extract that to a constant. Is there a code action for that? Nope. Let's put it up here somewhere random. Let's say like damage cooldown. And that was a quarter second. So one thing that you may have noticed is that you could get knocked around more often than you could get damaged. I don't think that's a problem yet, but we may want to think about that later. Yeah, health is 0. Okay, one thing I was thinking about doing is we could have the camera follow the player. I don't know how important that is now. Maybe we should think about player attacks and enemy hit points. So let's look at our directory of tiles here. And ooh, those are some nice like corner tiles and things. Cool. Pillars. What I want to find is a weapon our character can use. Yeah, so there's like a sword or a dagger. Bigger one, even bigger one, even bigger one. And there's like a wooden sword. It's like early Zelda 1 going on there. Okay, more enemies. You can get a hammer or an axe. Double or single bladed axe. Let's see what's going on there. I don't know what that is. Weird. It's like potions or something. I don't know what this is. Yeah, so here's the preview. I should have just pulled this up. Yeah, so we could give the player something like a sword. How they actually, we probably need to think about what the design of this attack is like. So like maybe the different um, different weapons do different things. What I think we could do, for example, in Vampire Survivors, your weapons just automatically. Yes, it is such an amazing resource, Chris. Like way back in the day, I may have mentioned in our early stream on this, I made a game, I guess you could call it, with a friend, and it was in Elixir, and we used Scenic for the visuals, and it was a capture the flag game, CTF game, and you had to write Elixir code that would control your tank character to try to capture the flag or destroy your opponent. And Kenny had some great assets for that. It's really cool that they make these for free, and they're great for prototypes. They're great for this sort of thing, like what we're doing, and it's just fun. So yeah, so again, so I was saying, like with Vampire Survivors, your weapons always fire. You don't have any control about whether they fire or not. Crafty Survivors is different. You can put them on autocast, or you can put them on manual. And in some characters that you use, you want them to be manual, and some characters you don't. Or certain skills you want to be manual, and certain other skills you don't. So I think let's start with the daggers, and I think what we'll do is we'll make that yeah. Let's use the dagger. Which one was that? And we'll just make it like fire in 4 directions. Tile 103. Okay, so let's put that in our dagger image. And dagger, something similar to this. Tile 103. Okay, so now we're loading. Let me make a commit real quick, since we did that knockback. Source combat. I really need to add things to it or get ignore. And did we modify health? Yeah, we modified health and main and movement. Okay. Let's just add the updated files, and we'll reset asset loader because that's our next step. Okay, so this is, yep. Okay, this is rewrite our knockback system when colliding. Okay, so now we're in here. We want to add tile 103. Tiles 103. Yep. Okay. So now we'll have our dagger. Interesting thing to think about on design. I think we probably want to have something like, because this the process combat comes before applying deferred updates, we might want to have our fire weapons in here, but we don't necessarily need it in this file. Maybe we can have it in the weapons file or in the player file. Let's put it in the player file because it's relevant only to players for right now. And let's say throw weapons. Throw weapon. And that's going to be process combat. Okay, so let's make a throw weapon one. And for now, we need to only deal with one weapon, right? So the player needs to be holding a weapon. So let's make a dagger component for now. And maybe and this needs a timer in it because we need a cooldown on that being able to fire that weapon, right? Let's say dagger weapon. Maybe let's just call it weapon, right? Because what we want is when this timer expires, let's make a const player attack speed or attack cooldown. Let's say you can fire every third of a second. So we'll want to give the player a weapon. Player attack cooldown, and then mode repeating. So the player can fire every 0.3 seconds. They can throw their weapon. Okay. So we are going to and let's make a marker struct. Just for this weapon, right? I know I haven't done ghost hit points yet, but we will deal with that. And we'll also want to adjust the health module so that we can have some sense of like how much health is deducted. Maybe we just do 1 for right now because ghosts will just have 1 health, and then you hit it once with a dagger and it's dead. But we'll figure that out. Okay, so what we want to do is we're gonna have a query, and I don't know what this is yet. Let's figure that out. We're gonna need the time as usual because we have to tick the timer on the weapon. So this is going to, we know it's going to need mute weapon, and We only care about players for now. If we need the enemies to be able to throw weapons, yeah, and maybe sometime later we'll have a component which is like a weapon type, um, and it's an enum or something. Okay, so if the player has a weapon, what we want to do, we know there's only one player, so let's just say weapon is query dot single mute. Okay, and always with that. Okay, so let's tick the timer. Tick time.delta. And we're going to need to spawn some new entities. So we're going to need commands here, like we did before. Okay, so if weapon.0.justFinished, because this is on a repeat, so we can't use the once, like the plain finished. We want just finished. Okay, if it just finished, then we want to spawn new dagger projectiles going in the 4 cardinal directions. So let's come up with a dagger speed, and let's say it's going to be slightly slower than the ghosts. And what we'll do, forward direction in, and let's just make a constant array here, vec3 x, vec3 negative x, vec3 y, and vec3 negative y. We're going to spawn. Whoa, I don't know what that is. What happened there, folks? Okay, so we're going to spawn a dagger, right? And it's going to have, we need a sprite bundle. So we're going to need this sprite assets in this system as well. So let's add that argument. Yeah. Okay. So it's going to need a sprite bundle. And the texture is going to be sprite assets dot dagger clone and transform. So we're going to have to figure out, we're going to have to rotate it, right? Because we want it to be going, like the tip of the dagger should be going in the direction that we want. So actually vec3y is going to be not rotated at all. We want it to, so we're going to need the player translation as well, or transform here, because we want it to spawn next to the player. So we're going to have to compute some things in here. And let's just say that, except that's too many dots. I don't think that we did anything. Yeah, we just did the transform and the texture. and we'll compute a transform up here. We'll figure out what it is from maybe what we can do is clone from and we need to get the player transform here. Player transform. And then actually, does this I guess we could probably do let's look at their transform documentation, because I think that there's probably some methods on this that we can reuse. We can probably use methods on quaternion to get a rotation. Okay, so this returns a modified. So this is like cloning essentially. Yep. So we could chain these together. Okay. Okay, so we could say with I'm going to do this. I'm not going to try to chain this together because I think we need to think about these problems very carefully. So I'm just going to clone the player transform, and then we're going to add direction times 16. That probably doesn't need to be a magic constant. Let's say it's actually well, player size is not going to work. That's used for collision. Let's call it dagger spawn distance. Any questions, please drop them in the chat about what the heck I'm doing. I realize I'm not like explaining a ton. Okay, well, player transform is copy. So there you go. Okay, so let's say this is dagger spawn distance. Why is that? Oh, here we need deref. Okay. So this will put it, so if it's going in the x direction, it'll put it to the right. If it's going the negative x, it'll put it to the left, etc. So we're getting a distance from the player's location. So it should spawn like one tile right next to it. And this is going to, we need to rotate it. So if it's going up, so Y. Okay, so I'm going to reorder these, and we're going to go in cardinal directions: north, west, south, east. So north, west, negative x, south, and I'll explain why in a second. Negative y, x. So this will mean that our local rotation for this will be we're going to enumerate, and this will give us the, let's say I don't really have a better name for it. So this is going to give us how many times we need to multiply the rotation. And we'll rotate by pi over 2, right? So let's say transform.rotate, and then we need a quaternion from axis angle. So the axis is, what type is that? Axis is vec3, so we're going to rotate around z, right? Because z is looking forward. And then we are going to rotate I as f32 times f32 const frac 2 pi. Frac pi 2? Yeah, pi over 2. Now let's leave this off at first and just see that they're spawning in the right place, and then we'll check our rotation there. Okay, so we need to we're spawning this dagger at sprite bundle. Yeah, frac 2, frac pi over 2, whatever. The documentation helps there. Okay, so the other bundles it's going to need a collider. And then let's look at the tile there. I don't think that it's, oops, what did I want to do? Look at the tiles. I had a Finder window open, didn't I? Yeah. So although the size of this is consistently 16 by 16, you note that the dagger is smaller than that. So maybe what we'll do is we'll say it is, and I can't really do this without getting a pixel editor out, a pixel bitmap editor. Let's see here. Open with preview. And let's zoom way the heck in. Okay. And let's do a selection and see if we can see. Right, so this is 8 by 13. If we... Yeah, let's just say it's 8 by 13. Okay, and then it'll be the correct size for the collision detection. Okay, so now we need a movement bundle. So the velocity is going to be from direction and speed. And we want to use direction, and the speed is going to be dagger speed. Glad we had that method made previously. Let's see if there's anything else that needs to be added to this. Okay, so we don't care about health. Yeah. Okay, so they should be moving in the correct direction. Yeah, we're not using that yet. It's okay. Let's just see if the boy, it's way too helpful there. Yeah, just so we use that eye and it doesn't complain, and then we'll put it in there later. Okay. Cool. So let's run this and see if we get weapons spawning. Look at that! Wow. Except he's running into weapons. Okay. So first of all, what did we notice? I think our spawn timer for the weapons is our attack cooldown is too small. So let's do 1 attack per second. Yeah, ow, 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 I hit my own weapons. Now let's apply that rotation as well. I was a little bit nervous about it, but rotation. Okay, so but we did verify that it is spawning on the correct sides of the player. So we may need to make some sort in our collision detection, or maybe our health and our knockback systems, some sort of classes of things that you can collide with. In the spaceship game tutorial, they really only care about if you're colliding with something of the same kind. But in our case, we don't want to collide with our own weapons. But we do want to collide with enemies. So maybe we will need to build out our domain language there a little bit, so that's a little bit clearer. Okay, let's see if we don't like spam with weapons and if they're kind of pointed in the right direction now. Okay. They're still firing a lot. Be careful. So you'll note that the ghosts do not despawn when they're hit by our weapon. So we need to look into that. That was fun getting knocked back by our own weapon. Okay. Oops. Command J. Okay. Something else we could have done here is go like pair up an angle there. But this is fine. I think it's clear enough. Okay, so we are spawning weapons. Now, we could probably look at this. And say, we look at our health, like our take damage, and maybe say, yeah, maybe what we want to do here is, instead of just saying, is it empty? We will want to filter The other thing that we could do is in collision, have some sort of thing like uh, a class of things. Maybe this is on the collider, right? The class of things that you can collide with, or a collection of things that you can collide with. Um, so that we could do something like, well, players can only collide with enemies. Um, daggers can only collide with enemies. Enemies can only collide with, or maybe this like, what can you take damage from? Um, our collision is really only about what you collided with, not whether that collision should do something. You know, here's what we could do. Let's parameterize our knockback collisions function, our system there, um, with so T is the type of thing that we want to knock back, and then C is a component, and we can say, so you can only collide with those things. You can only be knocked back by those things. And we could do the same on our take damage one, where we parameterize it by what you can be damaged by, right? So we could say, not there. So knockback collisions, players can only be knocked back by ghosts, right? So this right. So in this case, this would exclude the daggers from this second query. So we will not be knocked back by daggers. We'll be knocked back by ghosts. And I think I need to make sure that I import that. Import ghost. I think that I don't. Yeah, there's only one type on that phantom data. And a tuple of components does not implement component. um, so we may have to do something similar to what we did here. We'll say C, and then when we pull this out, we just ignore that. I really kind of wish it weren't like that, but that should solve that particular problem. Okay. So let's see if we'll run into the daggers or get knocked back by the daggers. We'll still take damage from them, I think, but okay. So we're no longer knocked back by the daggers, but we are taking damage from them. Cool. So now we need to modify the health. So what we want is maybe what we want to do here is have another query. So that's the query. We want to say enemies is the name of this query, and we're gonna do. It's just gonna be ghost for now. I don't really need. let's see here. Yeah, import that. So what I don't want to do is this. So we'll do something like if any iter any so this is going to take, so this is going to be an entity. If we say enemies dot, I think there's contains on query. Query. Contains, right? So you pass it an entity. So contains e. So if any of the things we're colliding with are enemies. Oh, and I need to like that. So if any of the things we're colliding with are enemies, then take damage. We'll want to generalize this. So let's go ahead and do that. So T is a component and E is a component. And we'll say this is with T and this is query E. And then up here, so we'll want to do player can take damage from ghosts. And let's make this a like this, because what we're going to do is we're going to make one where ghosts can get damage from daggers. So for now, hopefully if I didn't make any errors here, what we can do is make sure that we are not taking damage from daggers. So yeah. Okay. And this happens in process combat. Yeah, so we're good there. So let's run that and make sure that we're not taking damage from daggers. Okay, so we are colliding with the daggers, but we are not taking damage from them. But if we go over here and we run into a ghost, we're taking damage and we're getting knocked back. Pretty cool. Okay. Now it should be as simple as adding one for a ghost can take damage from a dagger, and then give the ghost some health. And then maybe we can wrap up with despawning things that have 0 health. So a ghost can take damage from a dagger. Okay. And let's go over into the ghost and give it some health. So this is going to be health new. And it's going to have one hit point. Okay, the health was, so this is take damage. And these can happen in parallel. And I think, I don't know if there's a way to say, Well, let's just see. I think this is correct. What's going on here? Mismatch closing delimiter. Okay. Something got mucked up there. Okay, so what we should see, and honestly here we can, let's add debug to this, because what I want to do is, rather than with t here, let's make t. And then we'll use that in our printout here. So health collider type. TY is probably fine. And then we'll do TY debug. So we can see the ghost getting hit by the daggers, right? In our printouts. That is not a trait. What is not a trait? Yes, it is. I guess I just need to import it. That's one of the weird things about the Rust prelude. Like, debug is something you can derive from the prelude, but the trait is not auto-imported. So weird. Okay. All right, let's see those ghosts hit some. It didn't work. Player got hit. All right, let's see what. Oh, we're getting knocked around. Okay. We got something going wrong there. Okay, so it has health collider and the thing, right? What is missing? Ghost has component and debug. All right. I don't care about camera right now. Yeah. So we are allowing a ghost to take damage from daggers. Maybe let's even put in here plus debug. And then we'll say by well, that doesn't help. Because we're just checking whether it contains that. We're not checking, we're not getting one. We could say if let some enemy enemies, and this would be find. Find map. And then we'll do get. Let's see their example here. And dot OK. Right. So then we'll say enemy. What I'm doing here is rather than just detecting if there's any, we're going to find the first one. And like this is just a marker component. So maybe there's like a different way we could do that. But if we get one out, then we'll have it here for printing out what kind of enemy it got hit by. I don't know if that's going to be helpful, but at least, yeah, because we're not seeing it printed player. Hey, player got hit, but we're not seeing the ghosts get hit by the daggers. And there's a question. The other thing we might want to put on here is that you can only get hit by something that has a collider. But we don't care what that collider is. One question in my mind is maybe this is we need dot. Well, but systems can be any, like tuples can turn into a bundle of systems, right? So I don't want to do chain. I don't think we need chain. Well, let's try this. See if we get anything. Move it up a little bit so we can see. Yeah, it's not hitting the ghosts. They're not taking any damage. I'm getting beat up. Yeah. Okay, so we never got any in output here that the daggers were colliding with them. Let's see, maybe we're missing. Yeah, Little Knight is getting thrown around. He totally is. Poor guy. So this has a collider. Let's look at our collision detection. We could potentially. I was going to say we could potentially debug some stuff about the dagger components, or the dagger entities, and see what's going on with them specifically. Yeah. Open to any ideas here. I'm kind of running out of steam. We are coming up toward the end of my usual 2 hours. I'm like happy to keep going, but I'm also kind of getting a little tired. This tuple thing is working because this one is running, player and ghost. Oh, here's the problem. Daggers, there are lots of them. Ghosts, there are lots of them. This was assuming that there was only going to be one. That's the problem. There are more than one. So we need to turn this let okay into a for loop, right? So we're going to change that. That is the problem. Yay, I figured it out. Okay. In query.iter mute. Thank Pete. Okay. Yeah, those quiet returns are rough. I thought about, oh, let's put a printout if we're returning. And honestly, I just need to put the entirety of this method inside a for loop. And I should have done that from the beginning, but like we made assumptions that it was only the player that was going to take damage, and that's not true anymore. So let's run that now. I think that should probably fix the problem. Come into my zone of death. Yes, yes. Look at them dying. Okay. I didn't mean to quit all of Zed. That was bad. I just meant to quit the app. Okay, so now I think we can do the last step, which is for things with 0. Let's go. Yeah. thanks for joining today, Chris. It is always a delight to see you. Yeah, so let's do in the combat system, or maybe in the health. Yeah, in the health here, let's say we're gonna do chain here. I didn't want to, but I think that this is going to be the simplest way. Despawn dead entities. Okay, and let's make this system down here dead entities. Okay, and the query here, we're gonna have commands. We need that, and our query is going to be you have health. That's it. That's the only thing we need. So for health in query.iter, well, actually we need the entity ID as well, right? Entity. And then we'll say entity. Okay, and then if health dot amount is 0, then we're going to do commands dot entity. Or no, it's a remove. That's entity. Despawn recursive. So yeah, that's pretty much all we need to do. So if the health of the thing is 0, then it gets despawned. When we do this with more sophistication, we can probably like maybe we want to have a death animation or something on this thing, and we'll, rather than despawning it immediately here, we'll like remove the health component and put a dying component on it or something. We'll see. I don't know, like if there's any. Then we could look at our tiles real quick. I don't know if there's any explosion type things or in this tile set. It doesn't look like it. Although that, like, if we start doing some generation of the map, that could be fun. Those walls look really cool, actually. Okay. So let's see if we can we don't need an info printout here, and I'm pretty convinced that this is working now, so let's remove that. Okay. Now, one thing that we need to change here, which is wrong, is we were returning from inside the 4. We need to do continue rather than return because we want to process all of them, right? And we can move that. We're not printing that out, so we can move that back in here. Yeah, that was for our debugging purposes. And we don't care about this right now. We'll just leave that. I think that yeah, that's fine. The other thing we could do is we could flip this back to the any. Let's do that. And then if collider. Yeah, since we're not using that. Okay. Yeah, so like if we wanted to do a death animation, we could do something like remove the health and the collision detection and then like put it into a state with a timeout where we show a series of sprites or something. I'm not sure yet, but for now they're just going to disappear from the screen. All right, so let's start sending some daggers out there. Look, and they go away. They die. Pretty cool. Yeah, so I think this is a good place to stop. We did a lot without committing. I think what I might do in a future step, maybe off stream, is clean this up, like only copy in the tiles that we care about, and we can keep the exploded tarball elsewhere, because that's cluttering up our commit stuff. Okay, so let's look at the diff. Okay, so we added the dagger. We are making our knockbacks only happen from players, on players, by ghosts. Right? We gave the ghosts 1 health. We can probably remove that debug stuff from our system. Interestingly, I think we have a bug here. Note that our health here is in post update. It needs to be an update. Otherwise, it's happening at the end of the frame rather than the beginning of the next one. I don't think that was a huge deal, but I think post update is for just like clean up stuff and not for actually running your game. Okay, yeah, let's remove that debug constraint. We're not using it anymore because we're not printing. Okay. Yeah, cool. We don't need this. And we can remove that constraint on it. Okay. Okay, let's make a commit. So we added weapons and enemy damage. Cool. I think that's a pretty good That's a pretty good description of what we did here. I know that's very reductive because we did a lot of things, but that's a great place to stop for the day. Let's look at our to-do list and mark that off. Player attacks, enemy hit points, and we have some stuff to do next time. So thank you so much for joining me today. Love to see the repeat um, attendees. Chris, always delightful to see you, and your experience is really helpful on this. Isaac, thanks for coming back, stream after stream after stream, and adding your thoughtful comments. And we will see you next time. I'm not sure when it'll be next. Of course, Sunday, which is my usual streaming day, is New Year's Eve. Probably going to be doing some fun stuff with my wife and possibly with my family. We don't know yet. And we're not going to be probably streaming that day. So probably wait until January 7th for the next one. Thanks for coming to this stream, and we'll see you again soon.